Let's take a look at another example of how we can use a phase diagram to make predictions about the physical state of a pure chemical under different pressure and temperature conditions. This problem, which is similar to one of your sapling homework problems, asks us to interpret the phase diagram of CO2, and the phase diagram of CO2 is shown in the bottom right-hand corner here. We're asked what phase does carbon dioxide exist in at 4 atmospheres and negative 10 degrees Celsius. If we start from the same point, the same temperature and pressure conditions, what phase change would eventually result from an increase in the pressure? So to answer this question, we first take a look at the phase diagram, and we use the x and the y axes to indicate the initial point, 4 atmospheres of pressure and minus 10 degrees Celsius. This can be a little bit difficult to do because, of course, the pressure scale slides a little bit to get everything in a single frame. But we can use as a reference point that the pressure of the triple point of CO2 is at 5.11 atmospheres of pressure. So if we're going to be at 4 atmospheres of pressure, we're somewhere along the line here, and negative 10 Celsius would put us somewhere around here, so we're squarely in the gas region. And that's approximately the point they're initially asking about. So based on the pressure and temperature conditions given, CO2 should definitely be a gas under these conditions. To answer the second question, starting from the same point, what phase change would eventually result from an increase in pressure, we're holding the temperature constant on this imaginary sample and we're increasing the pressure on it. The way we replicate that on the phase diagram is to draw an arrow straight up, or imagine that we're moving this dot straight up to a higher pressure. How high we don't know for sure, but just says would eventually increase. So we can read that to mean that we are going to get to increase the pressure as much as we want, and we want to know what phase change would eventually result. So we're increasing the pressure on this sample until we get a phase change. The way we replicate that on the phase diagram is to draw a line or an arrow straight up, and we would cross the liquid vapor boundary here, which would suggest that our gas phase CO2 would condense into a liquid with increased pressure. That makes sense because we know if we increase the pressure on a gas, generally it's going to become less of an ideal gas and more likely to condense into a liquid. So what the phase diagram is telling us makes sense in this case. So now we've moved our dot from there to there, and we would conclude that CO2 is a gas at 4 atmospheres of pressure and negative 10 degrees Celsius. Increasing the pressure on the sample will ultimately result in condensation, the gas condensing into a liquid.